Students, these are the preview notes for our next section. We're going to be talking about two-column proofs. We did informal proofs this past Monday and Tuesday. Next, we're going to talk about what are called formal proofs. Make sure you get a parent, a teacher, or guardian sign-off. Let's do a quick review. These sections below, I'd like you to go through and determine if the triangles are congruent by side, 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 angle, side, angle, or angle, angle, side. Please do the appropriate corresponding markings. You have 1 minute, go. Okay, let's see how you did. In this one, we have a pair of angles, and then we had a set of reflexive sides, and then we had another pair of congruent angles. So this is angle, side, angle. In this diagram, we had a pair of angles, and then we had a pair of vertical angles in the middle, and then we had a pair of sides that were given. So this one's angle, angle, side, or side, angle, angle, depending on how you look at it. This one, we had a pair of sides, and then we have a pair of angles, and another pair of angles. Again, that side is not squeezed between the angles, so that's also angle, angle, side. Angle, angle, side. This side, again, is not sandwiched between the angles, so it's a tail, not a hamburger. So both of these are tails. That's a tail, that's a tail, versus a hamburger. This one is a hamburger. Let's take these one step farther. Today we're going to talk about formal proofs. Key words you need to be familiar with is the given, the prove. You've seen that before. Given, what you're trying to prove. The acronym GIFT, given, implied, freebies, talk through. This is new, the concept of a two-column proof versus a web proof. And then a narrative. A narrative is what we did in class on Monday and Tuesday. A narrative is where you just write. So in an informal proof, a paragraph or a narrative which describes the how and the why of geometry. That's an informal proof. It has little structure. All you do is you just write and make sure your writing is detailed and specific. In a formal proof, formal proofs have a special style to them. They have a systematic diagram. It's a systematic diagram which explains the how and the why of geometry problem. There's two styles of formal proofs that we're going to be working with. Two styles of formal proofs. They have a systematic way and a special diagram. One's called a two-column, simply because you have two columns. On the left, you put the how. If you look in textbooks, it's also called statements. On the right, you put the why. In a textbook, it's also called reasons. In a web proof, is you have the different hows as chunks or webs. That would be the how. And the why you put as connectors between. So the why shows connection between, from this statement to this statement, why can you make that conclusion? So webs actually show how things fit together, how things fit together. So that's two-column, a web, and the two-column and the web are also called formal proofs. Now when we talk about the why, how do you find the whys behind this? You take a look at what's called the DPTP. The DPTP is that green section in your reference folder. It's called the DPTP because it's definitions, properties, theorems, and postulates. The face sheet of that page says a big fat Y on it. And in that DPTP, you want to look at headings. We have the different kind of headings: algebraic properties, how to show angles are congruent, more angle theorems, and then it has a section on how to show triangles congruent. This is what we just did right here. You really need to familiarize yourself with this packet. Okay, now I'm specifically going to teach you how to do a two-column proof called an algebraic proof, So you want to get this part of your DPTP handy. It's very small here. Get the larger version right underneath your nose. So that would be this section right here. It's on page 1. It's called different algebraic properties. So what you're going to do is you work out an algebra problem on the left. That's the how. And then you give the reason why on the right. For example, if we start with this problem here, 3 parentheses x plus 4 parentheses equals 72. And you see we distribute and then we get our next line. That's the how to do it. So that's a how statement. The why would be, I can take that step right there because of the distributive property. Okay, now look between the next two steps. From these two steps, we minus 12 both sides. When you do something to both sides, like minus or add, that is called the subtraction or addition property. So right here, if the quantities are equal, you add to both sides. That's called the addition property. If you subtract from both sides, that's called the subtraction property. If you multiply both sides, it's called the multiplication property. If you divide both sides, it's called the division property. So the reason I can do this is because of the subtraction property. Again, I'm answering the question why. Now you look between these next two steps and you ask yourself what happened between this step and this step. Well, you can see that we divided by 3 and we divided both sides, so the reason here would be division property. So in this proof, this answers the what. What is the question of what? What is the answer? And here, this is the how. And then on the right, you get the why. Why is this step acceptable? Let's try another one. Taking a look here. Okay, so we started with x minus 3 over x plus 1 equals 3 over 9. You can see the first step we did here is we cross multiplied. So how I got from here to here is called the cross multiplication property. From this step to this step, we see that we distributed the 9 and we distributed the 3. So what gave you the reason to go between these two steps? That would be called the distributive property. Then from here to here, you see we added 27 to both sides. I subtracted 3x from both sides. So we both added and we subtracted both sides. So it's the addition and subtraction property at the same time. You must say property because property means you're doing it to both sides of the equation. From here to here, we see that we simply divided by 6. So because we divided both sides, so we got 6x equals 30, and then we got x equals 5. What we did is we divided both sides, so it's the division property. So once again, on the left you have the how, and the right you have the why. What I'd like you to do here on the left-hand side is on the left I'd like you to solve step by step, and then on the right I'd like you to give the why. And again, here on the left I'd like you to solve step by step, and on the right you give the why. So you show your work between the steps, and then on the right you give which property is being shown, the why. I'm going to go ahead and set the timer for 3 minutes. You should be able to get both of these done in about that time. You may or may not use all the blanks provided. Okay, let's see how you did. So if you're going to solve this step by step, what you want to do here is let's go ahead and work this out. Of course, we distribute both of these. So that is going to be the variable a plus 6a plus 6 equals, and this is 3a plus 18. Now the reason you can take that step is because of the distributive property. Now our next step is we want to collect like terms. So we see here we can collect like terms, and there's no collect like terms. So we're going to simply, the property is going to be add like terms. And we get this. So we have 7a plus 6 equals 3a plus 18. So that's the reason for these steps right here. So now we want to get our variables on one side and our numbers on the other. So I'm going to minus 3a both sides. I'm going to minus 6 both sides. And that cancels and that cancels. So I end up with 4a equals, that's 12. And the reason I can make all those steps is because of the addition and subtraction property. Has to be property, because property means you did to both sides. Then the last step is we divide by 4, of course. And we have the variable a equals 3. And the reason we can do these two steps is the division property. So again, on the left is your how, on the right is the why. Let's see what you did here. Here we started with the fact that we can cross multiply when we have two proportions. And we get 9 parentheses n minus 7 equals 7 parentheses n plus 5. And the reason you can take that step is what's called the cross multiplication property. Then of course we distribute. And you have 9n minus 63 equals 7n plus 35. And what I did there was I, of course, distributed property. Now we're going to get our variables on one side and our numbers on the other. So I'm going to minus 7n both sides. And I'm going to plus 63 both sides. And that cancels and that cancels. This ends up being 2n equals, that's 8, and that's 98. The reason I can take those steps is because of the addition and subtraction property. And then last but not least, we can divide by 2. N equals, that's 98 divided by 2. 2 goes in there 4 times, that's 8. And 2 goes in there 9 times. Correct. Final answer is 49. And the reason we can do that is the division property. So once again, this is called a 2-column algebraic proof, in which you simply do the how on the left and the why on the right. Now let's apply this to something in geometry. Let's recap. When you do geometric proofs, it's really important you follow the principle of gift. Given, implied, freebies, and talk through. Given means you mark the given information and what you're trying to prove on the diagram. Implied, you mark what's implied by the given. Freebies, you locate and mark your freebies. Freebies is information that's always true even if it's not in the given. For example, vertical angles being congruent, reflexive sides congruent, the fact that linear pairs sum to 180, triangles sum to 180, that's all freebies. That's true even though it's not marked. Last and most important is take the time to talk through the logic of the problem. Actually talk it through. And if you find that this is really helpful to you, even on a test, I'll allow you to go and get in a private place and talk yourself through stuff. Because talk through helps you formulate your thinking, which helps you translate your thinking to writing. We're going to do two examples together. So our goal is to get through given, implied, freebies, and talk through. Let me demonstrate how this works. Given, the fact that line N and M are parallel. So that's L and L and M are parallel. So here's L, and here's M. Those are parallel, so I put arrow feathers there. We also know that we're also parallel to N. So all three of these are parallel together to each other. When you're done with a piece of information, get in the habit of crossing it out. I've accounted for that. Next it says line N bisects PQR. PQR. Start at P, go to Q, go to R. And this line bisects it. So trace and sweep. Last, we're told that the measure of angle, PQR, what you just traced, is 68 degrees. Cross it out. Our target is to explain how I know that both the measure of angle 1 and 4, because of this, is 34 degrees. So I'm going to put the 34 there. Now I can't use that as part of my explanation, but that's part of my proof, so I put a question mark by it. So then you just kind of go through some verbal reasoning. So we did given. Now let's talk about what's implied by the given and also freebies. And let's talk it through. Well, because of the bisector, I know that angles 2 and 3 both have to be 34 degrees. And the reason is because that 68 is cut in half. Then look, I also notice that if 2 is 34 degrees, then I have armpits of the Z going this way. And then if 3 is 34 degrees, I also have armpits of the Z going this way. And we can see if 3 is 34, that makes 4 34. And if 1 is equal to 2, 2 is 34, so you just carry it over. So we can see right now how we can hit our target. Look how much information I have on the diagram. It's really important you pay attention to this. When you're doing a proof, you should have no naked diagrams. Let's take a shot at writing this up. So we start with some of our given information. And not all of the given has to go in the first step. So number one, I'm simply going to say line L is parallel to line M, which is parallel to line N. And the reason I know that, because it's in the given. Now, from the parallel, I know that the measure of angle 1 equals the measure of angle 2, and the measure of angle 3 equals the measure of angle 4. And the reason why I know that is because if the lines are parallel, then you can say armpits to the Z, I'll take it, but the technical name here is alternate interior angles are congruent. Now we still have to get something else that's up here. We also know, number 3, that line N bisects angle PQR. We know that because it's given. And we also know that the measure of angle PQR equals 68 degrees because it's given. So if it's being cut in half and it's being bisected, step number 5, I can say that the measure of angle 1 must equal the measure of angle 2. And why do I know those two angles are equal? Is because of the bisector. So I can just write because of the bisector. And if we know those two are equal, we know that, not 1 and 2, 3 and 2, because of the bisector. So now we can say the measure of angle 3, which equals the measure of angle 2, both of those must measure 34 degrees, because that is half of 68 degrees. And then take a very close look up here. We just said 2 and 3 are equal, and we have, if I just said both 2 and 3 equal 34, and 2 and 3 are up here, we can replace that 2 and that 3 with 34. So that gets us our last step here, which is going to be step number 7, which the measure of angle 1 and the measure of angle 4 must equal, therefore, 34 degrees. And the reason is we swapped out 2 and 3 and we put in 34. That's called substitution property. Because we swapped out the 3 and put in 34, and we swapped out the 2 and put in the 34. And see here you have 1 and 4 now equaling 34 degrees. I think you need one more. Let's practice one more here. We are given the fact that angle, let's do this real close. We're given the fact that angles 2 and angle 3 are congruent. So I'm going to write 2 and 3 are congruent. And that DEG, trace and sweep, is congruent to FGE, trace and sweep. So all I have is those two equal. We want to explain how we know the fact that DG is congruent to FE. Well, there's a little trick here that says if we can call triangles are congruent, then the parts are congruent. So let's take these two triangles. See that yellow one? I'm going to pull it apart. Like so. And see this green one? We're going to pull it apart as well. I'm going to make them look face to face so it's a bit easier to spot these. So here we have D, E, and G, and then this right here is angle 3. And then here is FGE, and this right here is angle 2. And we were told that angles 2 and 3 are equal, so sweep, sweep, hatch, we have a pair of angles. We were also told that these large angles in the corner here, those are congruent, so double sweep, A for angle. Our goal is to somehow connect these two sides. Somehow, some way. So there's a simple property that says if I can get the triangles congruent, then I can say the parts are congruent, which would be these two sides. So we have to figure out a way, how can we get these triangles congruent? We marked our given. Let's check out implied and freebies. Look really carefully. Do you see that these two triangles sit on the exact same segment? Do you see EG? See EG? That's a reflexive side. So there's a side. So you used to see right away that the triangles are already equal because of angle side angle. And if you can say the triangles are equal, you can say the parts are equal. Let me show you how to write this up. So our goal is to go for ASA. So I'm going to start with my first set of angles. And I'm going to say angle 1 is congruent. Excuse me, not 1. It was angle 2 and 3 were congruent. And the reason why is because it is given. I'm going to put an A here for angle. Then I can say my side is equal. These two triangles share this side, and we're going to write it like this. EG is congruent to EG. That gives me a pair of sides. I know that looks a little strange. What that is called, that's called the reflexive property. It's a side that's shared by both triangles. Next, we have the two larger angles, DEG and FGE, these ones. So angle DEG is congruent to angle FGE. And the reason is it was given. There's another set of angles. So because of that, we can say that the yellow triangle is congruent to the green triangle, but we just have to watch our letters. So I'm going to go top, short down across, D, E, G. The triangle is congruent to the triangle F, G, E. And the reason we can say they're equal now is because of the shortcut angle side angle. Last, if the triangles are equal, the parts are equal. So now I can finally say that this segment here, DG, it has to therefore be congruent to FE. And the reason why would be if the triangles are congruent, then the parts of the triangles are congruent. That is actually a simple one to understand. If you look this up in a textbook, this actually phrase has a name. It's called CPC-TC. Corresponding parts of congruent triangles are congruent. But most students don't like the acronym because it sounds confusing. If you can just remember, if the whole triangle is equal, the parts are equal.